solve x square d square minus xd plus 1 into y equal to log x by x the whole square. So this is a differential equation with variable coefficients. This is a differential term. So this is a coefficient that is in variable. Okay, so we have to convert that variable coefficient into constant coefficient. For that we are using z equal to log z substitution method. This is a Euler's type. Okay, not Cauchy's type, but it is a Euler's type. About z equal to log x. So what about e power z? If you raise the power e, automatically it will become x. Okay, e power s, e power log x equal to x. E power log x equal to x. In both sides we have to raise to the power e. In both sides we have to raise to the power e. So e power log x will be a x. So this is one. Next, we have to apply this value in right side, but in left side this is a notation x square d square equal to, we have to take as d dash minus 1. So d dash square minus d dash x d equal to d dash. Substitute the value, simplify here. Here also log x equal to z, x equal to e power z. Next, bring the square inside the bracket, z square divided by e power 2z. A power nm formula equal to a power nm. So e power 2z. Okay. Next, bring this term numerator, z square into e power minus 2z. Okay. So 1 by x power n equal to x power minus n. We have to use the concept here. Okay. Next, we have to find the complementary function for this one. For that, replace d dash by m. So here replace d dash by m. Instead of d dash, we have to substitute m. So m square minus 2m plus 1 equal to 0. By using calculator, calculate the value. Here the highest power is 2, so we will get 2 values. In your calculator, it will show only one value, but actual power is 2, so we have to write that value twice. If it shows only one value, we have to take it as twice. Suppose power is 3 means twice we have to take. Okay. So complementary function, if both roots are same, so e power mx. So here what is a m? 1 is a m. So e power, instead of x we have to write z. Yes, it is in term of z. We converted. Okay. So e power, for both equations same, e power z ax. Instead of x we have to put z plus b. Okay, this is a process. If both are same, then this is a complementary function. Next, we have to calculate particular integral. Particular integral equal to 1 divided by d dash square minus 2d dash plus 1 z square e power minus 2z. We didn't see such a types. We haven't seen such a types. Two functions are there. As usually, we have seen only one function, but here how many functions are there? Two functions. One is z square, another one is e power minus 2z. So if we combinedly, we use one rule. Instead of d dash, we have to apply d minus 2. Suppose minus 3 is there, means d minus 3. D minus 3. Then bring this one left side, because its duty is over. For further operation, we should not use 1. Okay. So instead of d dash, we have to replace d dash minus 2. Suppose here plus 2 means d dash plus 2. Here 6 means d dash minus 6. Plus 2 means d dash plus 2. Minus means d dash minus 1. So in denominator we have to replace d dash equal to d dash minus 1. Why? Because e power minus 2z combined with another one function. But in previous problems we have seen only the one function, whether z squared or either z squared or e power a z or ax. But here two functions combined with. So this is the type. Actually it is a fourth type. Just learn that. Okay, this is the fourth type. Replace it. So the particular integral will behave 1 divided by, instead of d dash we have to apply d dash minus 2 the whole square minus 2 d dash plus 1. Which duty is over? Which one duty is over? E power minus 2 is a duty is over. So right here minus 2 is it. It's duty over. To vary it we are writing like that. Okay. To vary it we are writing that. Next. Z square is duty doesn't over. Okay. Next equal to e power minus 2 is it. Just work out here. A minus b the whole square formula. D dash square plus 4 a minus b the whole square formula. A square plus b square minus 2ab. Here a equal to d dash, b equal to 2. So d dash square plus 4 minus 2ad. So 2ab, 4d dash, 4d dash minus 2d dash plus 1. Next, 1 divided by d dash square minus 4d dash minus 2d dash minus 6d dash. Next, plus 4 plus 1. Sorry, here minus, sorry, plus 5 minus 2d dash plus 1. Minus 2d dash plus 1. Just to expand this term. Okay, expansion. Do it at rough work. Then write in main. Or we have to write one more steps. Okay. To avoid such a difficulties, just do it as a rough work. E power minus 2 is at 1 divided by d dash square. Add these two minus 8 d dash. Add these two plus 6 is a square plus 6 is a square. Okay, is it correct? Just once again verify. Sorry, one thing we did mistake. Instead of d dash we have to substitute d dash minus 2. D dash minus 2. So we forgot to apply d dash minus 2 here. So this is a small correction. So do it. Multiple inside the bracket. So what we will get? Minus 2 d dash plus 4 plus 1. Now d dash square minus 8 d dash. Next plus 10. This is a 10. Is it not? Okay, are we clear? Once again I am telling you, here two functions are there. Here how many functions are there? Two functions are there. So we are doing such a manner. Okay. Which manner? Instead of d dash we have to apply d dash minus 2. D dash minus 2. Okay. So wherever you find d dash, we have to substitute d dash minus 2. Here also one d dash is there. So d dash minus 2. Like that you have to bring. Is operation over? E power minus 2 is that operation is over. So bring left hand side. Further, we should not make this involved in any operation. Okay. Next we have to care this only. Next we have to care this only. So next we got like this. No. Next. E power minus 2 is at 1 divided by, here z square is there. Instead of x here is z. So it follows type 3. Type 3 says that we have to make the denominator in the form of 1 plus x inverse form. Is it not? So take constant term outside. Take constant term outside. Do any doubts? So here take constant term outside. 10 into, here 10 is a constant. Take it outside. Instead of 10 we have to put 1 plus d dash squared minus 8 d dash divided by 10 is a square. 10 is a square. Next, bring this term numerator. Bring this term numerator. equal to e power minus 2z 1 divided by 10 e power minus z divided by 10 brings this term numerator. So we will get 1 plus d dash square, just to split the term, d dash square divided by 10 minus 8 d dash divided by 10 inverse is a square. Inverse is a square. Already I explained you 1 divided by x power n can be written as x power minus n. So if we bring this term numerator, the power is 1. So that will be a minus 1. Here what is the square term? 2. What is the expansion? 1 plus x inverse equal to 1 minus x plus x square plus minus x cube plus etc. Is it not? This is a binomial expansion. This is a binomial expansion. Here what is the power? 2. So we have to stop up to this. We have to stop up to this. So e power minus 2 is divided by 10 into 1. Instead of x, here is a term like this. 10 d dash square divided by, d dash square divided by 10 minus 8 d dash divided by 10. We can cancel this one. 4, 5. Okay, we can cancel this one. Next, 1 minus bracket d dash square divided by 10 minus 4 d dash by 5 plus d dash square divided by 10 minus 4 d dash by 5 the whole square into z square. Is it common? This is a common term. Into z square is a common term. Next, we have to multiply z square inside the bracket. So e power minus 2z divided by 10 into z square minus multiple z square inside the bracket and minus inside the bracket. So okay, z square minus d dash square divided by 10 into z square minus plus 4 by 5 d dash into z square. Next, plus expand this term. What is expansion? A minus bd whole square formula. So d dash power 4 divided by 100 minus plus 16 d dash square divided by 25 minus 2ab. This is a this is a b, 2ab. So 2 into d dash square into d dash cube. 4 is there. 4 into 2, 8 divided by 10 into 5, 50 into z square. Okay, just to complete it. Okay, next we can move. If you have any doubt, you can ask. Still, listen. Here one careless mistake is there. To expand this term, we have did one small careless mistake. Corrected that d dash square, d dash minus 2 the whole square. We have to expand that term. D dash square plus 4 minus 4 d dash. Okay. Next, multiple minus 2 inside the bracket, minus 2 d dash plus 4 plus 1. So d dash square minus 4 d dash minus 2 d dash will be a minus 6 d dash. Constant term 4 plus 4 1 9. Bring 9 outside. So instead of 9 it will be a 1 plus for remaining terms d dash square minus 6 d dash divided by 9 because we have taken 9 commonly outside. Next, bring this term numerator. So it will be a minus 1. Okay. Next, we have to split the terms also. D dash square by 9 minus 6 d dash by 9. So if we cancel these two terms, 2 by 3 we will get. We will get 2 by 3. This is a binomial expansion. Find up to x square. Y. Here what is the highest power? 2. So find up to x square. So expand the term. Instead of x, here is d dash square by 9 minus 2 by 3 d dash. So 1 minus, write this term, d dash square by 9 minus 2 by 3 d dash. Next, squaring this term. Okay. Next, After squaring this term, we will get like this. Multiple z squared inside the brackets. 1 into z square, next multiple z squared inside the bracket and minus inside the bracket. So minus d dash square by 9 z square, minus into minus plus 2 by 3 d dash into z square. Next, this is a minus b the whole square formula. So use that formula, a square. So d dash square. So d dash power 4 divided by 9 squared 81. Like that we have to expand rest of the term. This is a minus b the whole square formula. In next step we have to multiple z squared inside the bracket. Okay. D dash represents differentiation, one time differentiation with respect to z. Okay. D dash squared represents two time differentiation. Okay. So d dash z square, because here z square is there. First we have to calculate d dash z square. What is the value? 2z. This is a differentiation formula, 2z. What about d dash square? D dash square z square. What is the differentiation of z? 1. So remaining 2. What about d dash cube z square? 3 time differentiation. This is a constant. So if you differentiate that term, 0. That's why I told you to stop up to second term. Okay. Afterwards it will become 0. So wherever find fourth term, it will become 0. Because what is a d dash power 4 z square? 0. So rest of the terms will become 0. So this term will become 0. This term also will be a 0. So remaining things we have to write. So the particular integral equal to e power z divided by 2z, e power minus 2z divided by 9 into z square minus, listen carefully, d dash squared z square. What is d dash squared z square? 2. So 2 by 9. Next, plus what is d dash z square? D dash z square 2z. So in front 2 by 3 2z. Next, plus these two terms will become 0. Already I explained why it becomes 0. Next, multiple z square inside the bracket. So d dash squared z square. What is the value for d dash squared z square? D dash squared z square 2. So they are 4 by 9 into 2. Next, equal to e power minus 2z divided by 9 z square. In 8, this will become 8. Add these two. 2 into 2 4 plus 4 by 3 z. What about 8 by 9 minus 2 by 9? LCM 9. 6 by 9, if you strike out 2 by 3, so plus 2 by 3, so this is answer. In your book they have taken LCM and move next step also. So e power minus 2z divided by, take LCM 3, so 3z square plus 4 plus 4z plus 2, 9. So what is 3 into 9? 27. So e power minus 2z divided by 27, 3z square plus 4z plus 2. So this is a particular integral. So what about the general solution? Z equal to, why we have to write as z? We converted that into z. Complementary function plus particular integral. So what is a complementary function? E power z, az plus b plus particular integral e power minus 2z divided by 27, 3z square plus 4z plus 2. Next we have to apply the substitution things. e power z equal to x, log x equal to z, log x equal to z. Here e power minus 2z there. So what about e power minus 2z? X power minus 2. What about e power 2z? X square. E power 2z equal to x square. So e power minus 2. So we have to convert y equal to e power, what is e power z? What is e power z? X. X. What is z? Log x plus b plus what about e power minus 2z? X, my x power minus 2 divided by 27. 3 into what about z square? Z equal to log x. Instead of z, what we have to substitute? Log x. So log x whole square plus 4 into log x plus 2. So this is a general solution. After finding the general solution, we have to convert that into x by using substitution method. Already I taught in the previous class. Okay. Yes.